Welcome to Securing Container-Based Applications. My name is Henrik Johansson. I'm a security specialist, solution architect here in Americas. And if I'm coughing, I apologize. Starting to hit the dry air Thursday. With me, I have Michael Capcoto, who's going to present the second half. I will make him have the intro. A little bit what to expect from this session. We're going to talk about OS and container security, as per the title. We're going to cover a little bit on the intro to container security and a number of best practices, what you can do to both reduce the attack surface and also secure the actual container instances. Discuss a little bit on container lifecycle security. That includes vulnerability analysis on the actual containers, how you can secure using, for example, certain partner tools, and how you can build that into a CI/CD pipeline. And then lastly, we're going to talk about managing secrets. How do you manage secrets on a container system? What's the main do's and don'ts? Then we're going to move on to infrastructure security. And Michael is going to take over and talk a little bit about enforcing governance with Amazon ECS and how to perform governance before you roll out your images. We're also going to cover using containers to automate security deployments. So how can you build a secure application flow using containers? That was it. So a quick intro to container security. How many people use ECS today or another container solution? Awesome. So I'm going to go through this very quickly then. A lot of people consider when they're talking about container versus VM isolation, a lot of people say that containers are essentially just small virtual machines. That's not really accurate. There's a couple of main differences here that when it comes to isolation. So for example, a container is implemented using Linux namespaces. That means that it has a slightly weaker isolation than a virtual machine has because they do run on a single kernel. So all the containers running on the same instance run on the same kernel. They also share certain files, sockets, memory areas, devices, etc. So they have a different security posture from the get-go versus a virtual machine. However, there are a number of, and I hope everyone can see that, there are a number of items that actually make the container solution more secure by default, just by the way containers are implemented. So we have, for example, the namespaces that handles the isolation for it. We also have the ability to add tools like SE Linux, AppArmor, SecComp. I'm going to talk a little bit later what they are. But we also have a lot of out-of-the-box default settings that will increase security on the containers. They come with the, for example, Docker, ECS, or whatever container solution you're using. You also have a lot more granular controls to control what they actually can do in the instance by either removing those binaries, for example, that you don't need to have. You can also control, in a very easy way, combination of security groups and with the Docker configuration and the ECS configuration, you can also configure ports on a more granular level. They also have no default SSH to containers. So there's no one that actually needs to access the actual files on there. Same thing with system users. You don't need to have the system users there by default in the same way you have with a virtual machine. And you have fairly easy to establish an immutable infrastructure by providing, for example, read-only file systems and locking down so there is no access to them. And you can easily do a rip and replace in case there is some concern with any containers. And the whole concept of containers is that you can just put them up and tear them down as you wish. So one way to handle this kind of security is defense through segmentation. So as I mentioned, they have a weaker isolation just because they use namespaces versus VM isolation. But you can still combine the benefit of running on a virtual machine with running on containers. A couple of items, make sure you keep containers up to date, but also the container instance. A lot of people tend to forget that they're running on an operating system, and also they tend to forget that they have to change the files in the actual containers. You can either do it yourself, or you can use one of the third-party apps out there to scan your container instances. Use IAM roles for tasks. We're going to talk about that later. Michael's going to cover that. We fairly recently launched IAM roles for tasks, which means that you don't have to put the IAM role on the EC2 instance only. You can put it on a task definition. And then segregate the containers. You can switch them out by, for example, role or customer, and have all the customers running on the same set of instance cluster. Or you can separate them on a risk, trust, and exposure level. I would highly encourage that even if you separate by customer or role, still break it down in a trust perspective. Go through what kind of exposure does this container have to external access? What kind of exposure does it have to other internal containers? Which containers does it need to talk to? And try to isolate according to that sort of trust model. Another way to handle this segmentation is that you do reduce the attack surface area for your containers. By default, they have a much smaller attack surface just because it's a service. It's not a full system. You can, however, reduce this even further by, for example, only contain the static binaries that you actually need. Rip out anything that doesn't have to be there. One example, so on the emulate drivers, is a case where virtual machines have a higher attack surface just because they also have much more resources running on them. So for example, there was something called the Venom attack a while ago, which emulated a floppy drive to get access to the system information. This was not affected since it's AWS. It did not affect AWS resources because we have restricted that kind of access. But it's a typical attack where by the fact of having much more resources and much more binaries and access to those binaries, you can actually increase the attack surface area by just running by default mode. Also harden the cluster instance. Follow, for example, NIST, SANS, whatever security best practice and benchmark you choose to follow, but make sure you do the proper hardening on the actual cluster instance as well. Don't just harden the container. And then use many but smaller instances to limit the blast radius. This is also from an availability perspective, that if one container instance goes down, and that's happened to be an 8XL, 10XL server, where you have hundreds and hundreds of containers, that has much higher impact than if you have a smaller number of containers spread out across multiple instances. But also from a security perspective, the more containers, the more roles you put on that server, the more your attack surface grows. A couple of other best practices. We're going to go through each of these individually. Limit resources by a way to reduce the attack surface by saying that the less resources you have on there, the less risk it is of sprawling processes, of someone trying to exploit other pieces of the system. Absolutely set it to read-only. Unless you absolutely have to write to that volume, set the file system to read-only. Limit container networking. There's multiple ways of doing that. You can do it using container settings and Docker and ECS setting. And you can also use third-party solutions to do this. Remove setGUID and setUID. As I said, if you don't need to change these system parameters, remove them from the container instance. Same thing here, set containers to run as non-root users, unless they absolutely have, and this also includes running in privilege mode. Unless you have a need to run something in privilege mode, don't do it. That gives the container much more access to, for example, system resources, to the actual Docker configuration, and to the Docker network and stack in those items. So unless you have to do it, don't run it in privilege mode. There are some products that use privilege mode, and it's third-party products, for example, to use privilege mode to increase the security posture. But for your regular containers, you most likely don't need to. And then use the Linux kernel security features like seccomp, SLinux. We'll cover those as well. Like I said, setting resource limits. In the task definition, you can easily set the CPU limit, basically how much CPU units you will have for that container. Same thing with RAM limits. And you can also set U limits, so for example, limiting like file cycle locks, or file size locks and mem locks. All of this is just to reduce the amount of resources available for someone to take advantage of if something happens. Read-only. You can configure this in the ECS task definition. It's a simple command saying just read-only file system, true. When you do this, it's going to map to the Docker setting, which is read-only rootfs, and also the Docker flag of read-only. But if you set it in the ECS task definition, that will carry on through and set the correct Docker flags for you. And again, if you don't need to write to the containers, set that as default. If you're unsure, set it to read-only, test it. Same thing with volumes you need to mount. On the mount point, there's a flag called read-only true. Same thing there. Make sure you use that when you add mount points to containers. From a networking perspective, we can also do a lot of things there. Of course, use security groups on the container instance itself, but also on a container level. We're going to talk a little bit on, in Michael's session there, how you can restrict this using proper governance in a pre-deploy scenario. So how you can ensure that the container task definition doesn't have unwanted network ports open. So this is absolutely a pre-deployment assessment that you can do before it goes out. Anything you restrict after it goes out will have a much higher impact on the security posture. Know the expected traffic patterns. Just know your applications. My usual recommendation is that your security groups should always match the expected application flow. So if your application expects to talk to a database server, that's the only thing that it should be able to talk to. And this should be restricted using both security groups, but also using IP tables, other filters, third-party tools, whatever it is that you can use, but make sure that you restrict that access. Same thing with north-south and also east-west patterns. One web server should never be able to talk to the other web servers just because they happen to have the same role. One really effective way to do this, and keep in mind that so there's a feature called ICC, so inter-container communication. This is enabled by default. This allows you to talk to other containers and have traffic between the containers. Unless you absolutely need to have open access for all the containers to talk to each other, don't set ICC as true, set it as false, and that's going to enable IP tables instead to handle the communication on a per container level. And then you just use link to say which container can talk to the other containers. And Michael's going to demo that as well a little bit. But absolutely use the link flag to restrict which container can talk to which one. You can also use third party to do that. Just put in a slide for a company called NeuVector, which is a third-party tool that runs as a container itself on the container instance to detect different types of threat from both external and internal networks and protect against like DDoS, cross-site scripting, and things like that. They will act as a layer 3 to 7 firewall and will detect. They have built-in security policy for over 30 applications and protocols. And it's kind of cool. They also will map. So we're talking about knowing your application traffic. They will actually map the traffic and detect the traffic going on the container and draw it out on a visual map so you can see exactly which container is talking to which one. And they can identify if it's, for example, an Nginx server or MySQL database. And by identifying that traffic, they can also say that this is the normal traffic that should go between a web server. If I start seeing other things, disable that or give you the option to disable that traffic. And it can also see that if you start having traffic going northbound instead of southbound, so for example, if suddenly your MySQL database is starting to call back to the web server, that can also be identified. And then you can just integrate that with, for example, a SIM or a log aggregator. Yep. As I mentioned, remove binaries that you don't need. Most apps absolutely don't need access to any of this. Whether it's setgid, setuid, or any of change owner, change permission, whatever it is that you need. Unless you need it, go through the image that you're using to verify if it's there. You can also use, this is a defanged Docker file configuration that just goes through and removes access to those binaries. This is a really common use case where people trying to do privilege escalation on container instances is by using those kind of binaries. Set a non-root user. You can do this in multiple ways. You can create the user using the Docker file, or just change the user via the user command, or set it in the ECS task definition. Just don't run as root by default. It's the same as with the AWS account. Don't use root. SecComp, so it's a Linux kernel feature. It got support from Docker in 1.10. It has a default profile that limits a lot of the different system calls. I think it's like a large library, basically. You can also customize this to have additional blocks on various system calls running on top of the cluster instance. You can also make a custom profile and set it in the Docker security option to point to that specific profile. We'll show you later how to enable that as well. SE-Linux, which implements the MAC, so mandatory access control, they have a default policy for Docker, which is designed to protect the host. You can use, for example, tags to restrict the usage on the containers. Excuse me. It enforces read-execute containers to the user directory as an example. There's a lot of different items that it will just protect the operating system from the containers themselves. And this is to prevent containers from breaking out into the operating system, which is essentially the biggest threat on a container system. It's someone breaking out of the container space. In order to use a lot of the security options, you can simply enable that in the ECS configuration. So there is actually a flag that says ECS SE-Linux capable equals true. If you set that, you do enable the integration with or you can enable the integration with SE-Linux. And there's a lot of other Docker security options as well that you can use. And anything that has support in the Docker security options, enable that and then just add them to the Docker configuration. Let's look a little bit on the container lifecycle. So what we mean with container lifecycle is knowing the application, the container flow from creation of container, implementation of container, follow up on them, but also where do you get your containers from? How do you validate that they are what they say they are? And how do you validate the content on them? Also studied recently, or estimated, over 30% of the official images in Docker Hub contains high priority security vulnerabilities. This maps to a lot of where do you get your containers? Do you simply use publicly available ones, or do you build your own containers? There is always a risk of using public ones because you did not create them. You also don't want to say, if you have an incident, that we were just running something someone else created, but he said it was trustworthy. A couple of the lifecycle risks here. From a build perspective, not just from a malicious perspective, but also from a just unknowing perspective. So for example, are the developers introducing new vulnerabilities in the binaries? Because it is the same as if you run an application in a regular host. You still need to do testing of the application. You need to do pen testing, static code analysis, whatever it is that you want to do to make sure that they're not adding vulnerabilities. On the shipping, for example, are they in are the containers vulnerable? Where did you get the containers from? Is it something that you copied over, or did you create them yourself? If you have, for example, in the run state, to have runtime defense in containers in case they are compromised, how do you rip them out? How do you detect? We mentioned earlier the non-vector product, for example. Can you say if a container that is actively running is vulnerable? A couple of mitigation process on the build. Do image vulnerability analysis in the CI/CD pipeline if you have a CI/CD. If not, run it manually. But do a vulnerability analysis on your containers. And of course, build your containers yourself. Own your repo. That's absolutely true. Don't introduce things that you don't know what it is. Don't add images that you haven't tested, that you haven't done scans on, and validated security of. Only allow developers to use approved images, so create base images for them to use. Don't let them build their own. That they can build their own, but then follow the same process as you have. Have a build process for them. Use configuration governance. So for example, if you use ECS definitions and container definitions, run them through a governance process where you can validate what's in them. So for example, see if they're trying to use port 80, see if they're trying to use libraries that are not approved and things like that. And then regularly analyze your images in your private repo as well. Even though you build them yourself, make sure that you have regular scanning on them. The reason is that there are also a lot of different libraries, not just that someone built an insecure information. There's a lot of libraries that someone discovers an exploit in. If you don't know exactly which libraries are running in all your containers, there's no way you can figure that out before they go out into the production lifecycle. So make sure that you scan them on a regular basis. Only allow compliant images run in production, of course. It sounds easy, but there's a lot of people that like, oh, I just needed to link to a separate container because I needed that feature, that database, whatever. And suddenly you have a sprawl of different containers that you don't know where they came from. Have runtime defense in place, of course. Either build it yourself, use a third party, and then just do regular checks against the industry benchmarks. One way to do that is Docker Bench. It's recommended by CIS, so Center for Internet Security, for benchmarking Docker images and Docker engine. You can basically use that to validate your host against the best recommendations on Docker Bench. You can build that actually into a pipeline using, for example, Lambda. So just invoke Lambda on a schedule, set it up to run once a day, once an hour, whatever it is, depending on how often you add new container builds. Run that Docker Bench command via EC2 run command, and then just take the output, put it into CloudWatch logs, and then you can create CloudWatch logs. So anytime you discover an alert from Docker Bench, just set up an alert in CloudWatch logs to send an email, or you can even trigger other actions, like, for example, tie it into CloudWatch events and trigger off actual actions on them to either take them down, go through and see where have they been deployed, stop those instances. So you can build a very long and effective automation chain using just, for example, Lambda and automation services. Another tool, so another partner we have is Twistlock. Twistlock does a lot of vulnerability management of the containers themselves. They also do compliance checks on the actual images. You can set up access control and runtime defense using their partner tools. It's a really effective way of knowing what you have. Doing pre-deploy scanning is really effective there. You can also scan the full repo for vulnerable images and have it set up to scan your private repo. Again, you can use NeuVector. It has ability to scan against like public CV vulnerabilities. You can also scan containers when they're running live. So it's basically scanning all the containers running on that instance to see whether or not they have insecurities or not. And also scans the host file system, not just the containers. The big strength of NeuVector is also the visualization that actually shows you how the containers are talking to each other, and not just on a single host, but also across multiple hosts. So if you have, for example, as we mentioned earlier, reduce the attack surface, so if you have your web services on one container host, and we have, for example, a database running on another one, it can still map out the relationship between those, and you can see the whole data flow. So I mentioned earlier building a continuous integration for it. Not going to go through to detail, but for example, if you have a developer pushes code into a repo, that it gets added to the CI/CD pipeline. You can use, for example, a Jenkins service to grab that information and build the actual container, and then call to, for example, the Twistlock API to scan that application automatically before it does the build. Before it takes that build and pushes it out to the container repo. And then once you've done an analysis, verify that there are no vulnerabilities inside the Jenkins app, then push it out into the build cycle. If you look at it more from a full-time perspective, this is just an example. Same thing with the partners. These are example partners. There are, of course, more partners, but they're good products. Use code commit for your container source. Then use, for example, the Jenkins flow, where you do pre-deployment assessment using the Twistlock, using a Lambda function, check the image for vulnerabilities, and then push it into ECR or whatever repo you're using. And then just make sure you update the ECS service via CloudFormation. It's a really good way to make sure that it follows your standards. You can also scan the CloudFormation template using the same governance practice. Then push it out into a run environment. Use, for example, a product like NeuVector or whatever you want to use, of course, and then do live scanning to see what they're actually doing once they're out in production. Quick note on managing secrets. There's a couple of different ways of managing secrets. For example, bake into the image. No. Do not put your secrets into the image. Just no. You can also set it in environmental variables. Keep in mind, though, this is suggested by a number of different parties. Keep in mind, though, that if you put it in a variable, it can be seen in a lot of places. It also gets captured. So even though you set it up so no one can access that server, well, they take a snapshot, deploy it somewhere else, and they have access to it as well. So try to avoid that as well. And also, you can't delete them from the running one. It's way too visible. It's also visible through API commands. So avoid putting it in environmental variables. You can, however, set it as an environmental variable, but reference something else. So for example, if you set it as an environmental variable, but you point to a S3 bucket and an S3 bucket file, you can simply have your application fetch it on the fly by using either EC2 roles or using IAM roles for ECS tasks. That way, the secrets are never stored on the actual instance as stored files or stored variables. They will not be captured. You can't access them through API. They will fetch them on a runtime perspective. And you can also use VPC endpoint for S3 to lock down that access even further. And that's going to be all logged because you're using the IAM access to access the bucket. Everything will be logged as well. There's a blog down there. You're sure can't see it, but you can see it on the recording after, if not, or the slides on SlideShare. There's also a number of third-party instances that you can use. So you can, for example, use Vault from HashiCorp, Kiwiz. There's a number of different partners out there if you don't want to build your own. You can, of course, also build your own system. It's absolutely available. But keep in mind that if you don't know what you're doing, it's probably better to look at a partner. If you feel comfortable with it, build your own. Like I said, building it using S3 access is not that hard. Quick note on how you build this. It's not hard. You have your MySQL instance, you have a Vault server, and you have your application. Just make sure that you route everything. So when the application needs it as the Vault, in this case it's Vault server, but if you build this yourself, this could be replaced with, for example, a Lambda function that you invoke. It could be the Lambda function that fetches the data from S3. Just be creative. Use external systems. If you were to use a Lambda function, you can have your application make an API call, and then to the Lambda function will actually fetch the secrets using, for example, KMS, using DynamoDB or S3, and encrypt all the information, and then return the information to you using the API commands as a return value to the application, while the Lambda function is responsible for handling all the secret management. So you can build it on your own if you want to, or use a third party. I'm going to hand it over to Michael, who's going to talk a little bit more on enforcing governance with ECS.
Thank you.
No, you don't need that, actually.
Hey, guys. I don't know if this is on. Can everyone hear me okay? Yeah, awesome. So my name is Michael Capicato. I'm a solutions architect at AWS. And so far, Henrik spoke to you about how you can actually secure your Docker images and your running Docker containers. The piece that I'm going to talk to you is a little bit lower down, and that's how can you enforce governance in AWS using Docker and using ECS. And then we're going to cover how you can actually automate your security deployments in AWS by taking advantage of some of the advantages Docker offers. So I'm sure there's a bunch of you in the room who have used ECS before and you're comfortable with it, but I want to do just a quick recap so everything I say kind of makes sense to everyone. In ECS, we have the concept of a cluster. This is just a group of EC2 instances that you run all of your Docker containers on. And you do this by creating what's called a task definition. Task definition is almost like a CloudFormation template. It's a file that allows you to specify what Docker images you're going to use, where you're going to deploy them, what kind of CPU and memory limits they have, and also, very importantly, what kind of communication can happen between those Docker containers and what port mappings they have to the underlying instance. And these two pieces are what I'm really going to focus on. So once you created that task definition, you can point it to containers. You might store those in the ECS container registry. And one task definition can reference multiple containers. It doesn't have to be just a single running container in a task. And you can then deploy a task onto that ECS cluster. And on the same ECS cluster, you can deploy more than one task, right? You can have as many as you want, depending on the size of the cluster and the memory and CPU limits you set. So I hope that was a okay primer. Now let's talk about governance. So if you want to actually enforce governance in AWS and ensure that everyone deploying their applications and their security software is following your best practices, you can actually take advantage of that task definition. Any modification that someone makes to the ECS task definition is an AWS API call, and that can be controlled via IAM. So you can do things like enforce which Docker images are going to be used. You can allow people to execute that task definition, but not to modify the reference in it to what Docker containers it's pointing to. And this allows you to ensure that those Docker images that the task definition is pointing to are always tested from a security perspective. You can also, as Henrik mentioned, control the CPU and memory limits that the container is going to use. You can control those container links to each other, so which containers can communicate with one another. And also port mappings. This is really important because by default, if you leave the port mappings in the task definition blank, that means all those images you're deploying, those running containers, have no access to the underlying instance ports, which means they can't communicate with the outside world. And there's also the ability now to specify within a task definition which IAM role that task is going to use. And this is super useful. So I want to show you guys why. One of the first benefits is that you simplify the usage of the AWS SDKs. So if you have application teams that are writing apps that reference the AWS SDKs, before we release this feature, you would have to either hard code credentials into your container, which is obviously a bad practice, or you would have to attach an IAM role to the underlying EC2 instance. With this feature, you no longer have to do that. You can attach the role to the task itself. Oh. Cool. You also have credential isolation between tasks. So previously, all tasks running on a single instance would be using the same underlying role. And that would show up in CloudTrail as, this role executed this API call. You would have no idea which of those running containers actually executed that API call. So from an audit perspective, it made things very difficult. And also from an authorization perspective. Traditionally, you would have to allow every running container on the instance full access to the entire role. So you couldn't specify that this container can only make these API calls, but this other container can make its specific API calls. They would actually cross-reference each other. And I mentioned the auditability already. So the old way looks like this. You have a running cluster instance, and you would deploy a task with maybe a web UI or some sort of app on it. And then maybe you had another container running in a separate task on that same instance. Maybe the web UI container had some static content stored in S3 that it would have to use S3 API calls to reach out to and grab. And maybe that data insights container would be making calls back to a DynamoDB database to fetch information. That web UI container in the old model would be able to access DynamoDB because they would be using the same underlying IAM role attached to that cluster instance, and vice versa. The data insights container would be looking at S3. This is, of course, undesired. You don't need this kind of cross-reference. And the reason that that was there is because that IAM role was actually attached to the instance and not the task. So this is the new way, right? We've released this feature that allows you to specify in each task an IAM role. And that allows you to ensure that the task only has the API privileges that it actually needs, and you can run as many tasks as you want on the same EC2 instance, but they don't have conflicting permissions. And since this is a 400 level session, we want to explain how this actually works, right? The first thing that happens is on your EC2 instance that you're using within ECS, there's an agent that will talk to the ECS control plane. So it's going to periodically query the ECS control plane and ask for those credential files. And the control plane is going to generate a unique ID token for every container running on that particular instance. That's going to get passed back to the ECS agent on the instance itself, and that credential is automatically rotated for you. So of course, better than hard-coded credentials that are long-lived. The ECS agent is going to do two things. First, with that ID token, it's going to construct a unique HTTP URL. And it's going to set that URL in a local environment variable so that each container running on that instance has a path to pull its specific role that's getting auto-rotated in the backend. And of course, the SDKs that you use within those containers are smart enough to just automatically pull that role. So when your developers are building applications, they don't need to set any sort of local variables that point anywhere to fetch credentials. The AWS SDKs are built in such a way that they'll automatically pick up on that and fetch those credentials for you. So I'm actually going to do a quick demo for you. So I've actually already got a running cluster here. And what I'm going to do is just demonstrate how these IAM roles for tasks actually work. So I've got two different task definitions here. And the first one is called demo A. And I just want to show you quickly, this is just deploying a basic Nginx Docker image. I haven't made any modifications to it. And it's exposing port 80 so that we can actually see it from an HTTP URL. And it's taking advantage of CloudWatch logs. So the demo I'm going to be showing you is an Nginx container that's pushing the Nginx logs into CloudWatch logs in real time. And you can set this right down here by just specifying a CloudWatch logs group and the region that you're operating in. Now, the important thing is that you can see here I've specified a task role for this task definition of demo 2A. And if we dive into that, okay. Great. So we can see that this role that I've attached has a full access policy to CloudWatch. So this role is going to allow the task that's running with it to write those logs into CloudWatch. So I'm going to flip back to the ECS console, and I'm just going to run this task definition on my default cluster. And it's probably going to take about 15 or 20 seconds to move from pending to running. And essentially what's going to happen is when it's running, we're just going to get the base Nginx page. And I'm going to refresh a bunch of times, and then we're going to see those logs getting pushed into CloudWatch. So that's running now. I'm just going to grab the DNS endpoint for that EC2 instance, and there's the base Nginx page, right? Now, the important thing is if we go back to the AWS console and we go into CloudWatch logs, and this is that ECS logs group that I referenced in the task definition before, we can see that a new log stream has just been created at 108. And there's a few records in there right now. So what I'm going to do is I'm just going to refresh this Nginx page like 10 times. And if we go back here, we should see those pop up. So this is basically demonstrating that that running Docker container is using the permissions in that IAM role to write these CloudWatch log files. Now what I'm going to do is I'm actually going to stop that task. And I'm going to run the exact same task, but with a role that doesn't have access. And that's demo 2B. And if I show you that role for demo 2B, I just put a policy in here that has S3 full access. So this container is using an IAM role that gives it access to S3, but not to CloudWatch. And I'll run this task. This should go a lot quicker because it's already loaded the image. And now you can see we've got this Nginx page. Let me just refresh that a few times. And back in that CloudWatch logs group, we can basically see that there's no new logs getting added, right? All of the logs that are there were there. And the actual task that's running and the container that's running has no permissions now to write to CloudWatch logs. It's running on the exact same underlying EC2 instance. And that EC2 instance actually has full permission to write to CloudWatch. So it's getting blocked at the task level. So there's one more piece I want to talk to you guys about today, and that's automating your security deployments. And this is going to get your security teams really excited internally, because it's going to let them deploy the functionality that they have built into their InfoSec policies without talking to any of your application teams and trying to integrate with them. So Henrik spoke a little bit about the continuous integration piece, right? Having developers and other teams push their updates into something like a code commit repository or another Git repository, and then having Jenkins pick up on those changes, automatically build those Docker images, do any sort of security checks, and push them into a container registry. You can also have Jenkins do things like validate that the task definition only contains secure ports, right? And it doesn't have port 80 open, for example. And then check that task definition back into source code control so that you have a living, breathing version of it somewhere. And this could all be done by your application team. But imagine for a second that your security team now follows this exact same procedure. So maybe they want to deploy a host-based intrusion detection system. And traditionally, they would have to work with the application teams to bake that into the images that the app team is using. With Docker and with ECS, you can avoid that, right? You can have that security team or InfoSec team build a Docker image and a task definition that contains their software. At the same time, the app team, whatever they're building, they can build a Docker image and a task definition as well. And you can use an automation framework like Jenkins to pull down both of these Docker images, merge the two task definitions so that they're using and referencing both of these containers or images, and automatically deploy those out to ECS. So this allows these teams to operate and iterate independently of one another. And there's quite a few benefits to this that I'm going to talk about. But first, I'm going to show you an example. Imagine you wanted to set up or you want to run a web application, but in front of it, you want to have some sort of throttling so that you mitigate denial of service type attacks. You would run a cluster instance, and you could run a single task on that instance with a web app container, right? In our case, when I demo it for you, it's going to be a simple PHP application. And what we're going to do is we're going to build a reverse proxy container that has throttling enabled. And we're going to force all traffic coming from the outbound network to go through that reverse proxy container before it talks to the PHP app on the left. And we can do this simply by controlling port mappings and container links within the ECS task definition. So let me show you that now. So the first thing actually that I want to do is go back to task definitions. I have two revisions of the same task definition. And the first one just contains a single container with a simple PHP application. So I'm going to deploy this first so that you can see what it looks like without any sort of throttling. That's probably going to take a few minutes. But I'll explain the demo. What I'm going to walk through is, this PHP app is going to come up, and I'm going to hit refresh like 1,000,000 times, and it's just going to keep serving me the page. And you can imagine a denial of service attack operating in a similar fashion, right? Whole bunch of requests coming from an IP address, and you would like to throttle that type of thing. So this should switch over to PHP. And I can hit refresh at will. It's never going to throttle me. So this is just direct access via port 80 to this PHP application. And I have another revision of the task definition that actually contains two containers. So it contains the same application container, but in this case, it has no port mapping. So that PHP container is now not exposed to any underlying port on the instance, and thus it is unreachable in and of itself. But there's a second container here, and this container just contains Nginx set up as a reverse proxy, with throttling enabled. 3 requests per minute are what's permitted, and anything above that is going to be disallowed. So there's a few important things. The first is this link. This link allows the Nginx container to communicate with that PHP application container. And this is where the port mapping is exposed so that we can actually see it. And what we can actually see now is that there's 2 containers, and my screen's far too big. But let's see if we can just get them both running. All right, so I think they're good now. So what I'm going to do is refresh this page a few times. And you see after the 3rd request, I get this 503 error, right? So now that Nginx container that's functioning as a reverse proxy, all outbound traffic is going through that. And you can imagine this being not just a simple throttling container like I set up, but your security teams building in their intrusion detection systems, their web application firewalls, their logging and monitoring solutions, whatever they want really, completely independently of your application teams. And I can actually quickly show you guys what the Nginx configuration file actually looks like. So this is the line that matters, right? It's doing that request at 3 requests per minute, and any more than that, it's getting blocked. And it's proxying everything through to the application container, which is the name we gave it in the ECS task definition. All right. My demos both worked. I'm really happy. So you might be saying at this point, well, why should I care about this kind of stuff? I hope I made that clear so far, but if I didn't, let me recap. First of all, you're going to remove any accidental conflicts. Traditionally, you would have your security software and your application running on the same operating system. Maybe there's port conflicts. Maybe they're using different versions of the OS. Maybe they're using different backend libraries. This just creates a nightmare for the security team and the application teams. And they can now operate independently of one another and produce containers and Docker images and iterate independently as quickly as they'd like. And that makes the security processes continuous and automatic. Every time there's an update to my web application firewall, my intrusion detection system, the InfoSec team can just go and build and push that Docker image out, and it doesn't affect any of the application teams. It also allows you to encapsulate these software artifacts, right? Your application and your software, your security software, and you implement the controls one level up within the actual task definition. And this allows you to control the entire framework via IAM. So you can give developers the ability to edit their Docker containers, but not the ability to modify the task definition. And since they can't modify the task definition, it ensures that they're always going to be also integrating the security containers that you've built and not using any insecure ports. You can do that by using Jenkins to check before a deployment. And this process works not just for containers. I know this is a container session, so I don't want to spend too much time on this, but imagine you're not building Docker images today and you're using Amazon machine images. You can implement the same type of control in CloudFormation, right? Of course, we spoke about Docker images using ECS, or maybe you're just building applications, saving your OS packages in S3 or source code control somewhere, and you're using code deploy to push them out. The point is you have a software artifact at some point that you're deploying, and you have a service in AWS that you use to deploy it. And when you use, oh, well, that's terrible animation. When you use CloudFormation, right, you would regulate the CloudFormation template. Ensure that only approved Amazon machine images are being used, and that they have appropriate security groups connected to them. With ECS, we talked about controlling the task definition, controlling those port mappings, and any references and CPU and memory limits, that kind of stuff. And if you're using code deploy, there's also a very similar model. The appspec.yaml file or application specification file. This is what code deploy uses to point to different repositories of code that you're going to deploy, different scripts that you're going to run as a checking process. So you can control all of these definitions or templates and ensure that your security policy is being enforced via them. So Thanks a lot for listening, guys, and please remember to complete your evaluations. Thank you.